The way that I measure resistance is by measuring voltage and current. So here's an example of an experiment that I could do. So I could take some circuit device, I could apply a current and measure a voltage, or I could apply a voltage and measure a current. So then what I would do is use Ohm's law, so V equals IR, in order to calculate the resistance. So the first thing I should do is check that I have this the correct sign by the passive sign convention. So I look over at my circuit diagram and I see that the current enters the positive terminal of the way that the voltage is labeled. So I should use V equals positive IR here in my calculations. If I want to solve for resistance, then I find that it's V divided by I, so that's just rearranging Ohm's law. And now I can take any of these values from the experiment that was done. So let's suppose I take this one here, then I can substitute that in and calculate what the resistance would be. So for instance, I could say 40 divided by 10, which would give me 4 ohms. I could also have taken one of the other values of that experiment. So for instance, V over I, let's say this next one over here, then I would have 20 divided by 5, and I get the same answer of 4 ohms. And so I get here the same answer because this material is a true ohmic resistor. So if I was to get a different value, then it would mean that this is a material whose resistance varies depending upon the voltage. So that's not kind of pure true ohmic behavior. But because I would get the same value regardless, this means this is a kind of a perfect resistor, a correct ohmic resistor that is completely described by Ohm's law by V equals IR.